This is the review of how to find the determinants for 2x2 and 3x3 matrices. Let me just clear my screen here. And we'll start with 2x2 matrices. For 2x2 matrices, there's 3 steps that you want to follow. First, you want to find the product of the major diagonal. That's the diagonal that starts in the top left corner and goes into the bottom right. Second, find the product of the minor diagonal. That's the diagonal that starts in the top right and ends in the bottom left. Bottom left. And third, you want to do the major. No, that's right. Major diagonal minus minor diagonal. So these are the 3 steps for a 2x2. Just write 2x2 on top. So you want to find the product of the major diagonal here, product of the minor diagonal, and you want to take that product of the major diagonal minus the product of the minor diagonal, and that's how you find your determinant. Determinant for the symbol looks like this fancy D here. That's the symbol for determinant. So let's look at an example for a 2x2 problem. If you're given a matrix like this, let's say it has 2, -1, 3, 1. Okay. If you want to find the determinant of this can be rewritten as 2, -1, 3, 1. The only thing that changed is that it's no longer, The only thing that changed is that it should no longer be in brackets. It should be in these absolute value looking bars, but for a matrix, they're not absolute value. They're, it shows that it wants the determinant of that matrix. So we're going to follow our 3 steps. The first, we want to find the product of this major diagonal. So all we have to do is do 2 times 1. We find 2, because 2 times 1 is 2. Erase this here, just to keep it simple. Then we want to find the product of this minor diagonal, and we find 3 times -1 equals -3. Then we move on to our 3rd step, and we do the major diagonal product minus the minor diagonal product, and we get 2 minus -3, or 2 plus 3, since it's double negative here, equals 5. So I'm going to do another one real quick. Let's say we're given something like 1, 4, 3, -2. Oh, sorry. Drawing in those brackets there. Determinant. So we want to find the product of the major diagonal, which is 4. Product of the minor diagonal, -2 times 3, -6. Then we want to do 4 minus -6 equals 4 plus 6 equals 10. Our determinant equals 10. Pretty simple for 2x2 matrices. Just once you get those steps down, it actually makes the 3x3s a lot easier, because if you actually follow it along, the steps are very similar. So let's move on to that, and I'll show you what I mean. 3x3 matrix, let's say numbers like okay. So there's our 3x3 matrix. It's inside the absolute value looking bars, so it shows that it's looking for the determinant. So remember the 3 steps that we had for the 2x2. We wanted to find the product going this way, the product going this way, and then subtract them, right? So we're going to actually do something very similar, but in order to do that, first, we have to move this bar. We want to erase that bar. And we want to rewrite our 1st and 2nd columns. But it's important to make sure that you write them in this order. This is the 1st column, 1st. This is the 2nd column, 2nd. we want to do our first column and then our second column. So you should be left with 5 columns, 3 rows. And it's important to write it that way, and you can check to make sure that you don't write it that way, write it the wrong way, because if you do the second column and then the first row, your determinant will be 0. So that's just a quick check that you can do in order to make sure that you're doing it the right way. So the steps for the 3 by 3 are as follows. You want to find this product. You want to find this product. You want to find this product. Add them. Okay. Just like that, that's just like what we did for the 2 by 2. So you want to find this answer down here. But instead of only having 1 major diagonal, we have 3 major diagonals. Okay. Now that might be a little messy to follow. So let's just do that right now. Our 1 diagonal is right here. So you start in the top left, you go down 1, over 1, down 1, over 1. That's how you get your numbers. So you get 3 times 1 times -1 equals -3. Erase this just to keep it simple. Then we want to look at we want to shift over to the right one to find our next diagonal. Find 1 times 2 times 1. That little thing there. 2 times 1 times 1 equals 2. So we got -3 plus 2. Okay. Then we got 1 more diagonal we need to find. There should be 3 diagonals going both ways when it comes to a 3 by 3. So our next diagonal is going to be this one. -2 times 4 times 3. -2 times 4 equals -8. -8 times 3 equals -24. So we're going to get -24 here. Add these together. Well, technically this is plus -24, but that can be omitted because it just turns right into a negative. So that's going to be -27 plus 2 equals -25 for the bottom. That's only for the bottom. That's not your whole answer yet. Going the other way, you want to find this diagonal, and this diagonal, and this diagonal. Remember how for the 2 by 2, the minor diagonal started in the bottom left and ended in the top right? It's the same thing for a 3 by 3. So you're going to start in your bottom left, 1, 1, -2. Start in your bottom left, go 1 right, up, right, up. That's how you find your numbers. So you got 1 times -2 equals -2. Erase this. Move over 1. You get 3, 2, and 3. 3 times 3 equals 9, times 2 equals 18. So -2 plus 18. And then 1 more. -1, 4, and 1. That last row. -1 times 1 times 4 equals -4. So -4 equals, so 18 minus 6 equals 12. So we're left with -25 and 12. Let's not do that yet, actually. So for each directions, you should have the 3 diagonals. You should have the 3 major diagonals. And when I say major, all I mean is it starts in the top left, ends in the bottom right, and the 3 minor diagonals. So they start in the bottom left, end in the top right. And now, just like with the 2 by 2, we're going to subtract -25 minus 12 equals -37. It's a big one, but I just chose these numbers at random, so we don't have to go any further than this. But our determinant for this one would be -37. So just like I said, remember, make sure that it's the first column that gets repeated first, then the second column. Always a good idea to go through and make sure that your numbers are all right. So 3, 4, 1, 3, 4, 1, 1, 1, 3, 1, 1, 3. It's all good there. And we'll see how later on this determinant can be used for things like finding inverses and using it in Kramer's rule. But it's important to understand how to do it right now, otherwise you can't move on to other things.